Hello everyone, welcome to my YouTube channel, and today's video is about Google Cloud Platform. So this is the very beginning of our cloud journey. So in this series all the videos will be recorded in English. I have no plan to record videos in any other languages at this moment, so we'll see in the future how it goes. If you do not have any prior database experiences, for example any relational database system experiences, I would say you could still continue watching these videos. So this video is more focused on the hands-on rather than the theory, but I covered most of the theory when I do the hands-on. So that you get the idea why I do certain things this way, why not other way around, right? So remember that Cloud SQL is a fully managed serverless relational database. Serverless in this case, users like customers do not have to manage any kind of servers. The cloud service provider, in this case Google, will handle it for us, and Cloud SQL has pretty good integration with other services within the Google Cloud ecosystem. For example, we could use Cloud SQL for GKE or even Google Cloud Run, for example. To provision the database instances, we just need to say how much memory, storage, and CPU we would need before we provision the database instance, and everything else is actually handled by the cloud provider, so in this case GCP. So everything is pretty much covered in the hands-on, so I would not repeat those things right here. You will get them later on in this video. So let's look into the today's agenda without any further ado. So in today's video, I'm going to show you how to create the database instance. So once you create the database instance, I will show you how we could create databases, we could create users, how we could also create read replica. Later on in the video, I explained what is read replica, how you could promote read replica, how you could stop a read replica, or how you could update the size of the read replica. Once we have the database instance provisioned, we want to connect to our database instance, let's say from our home computer. So therefore we need to whitelist IP addresses. I also show you how you could do that. Apart from that, I also show you how you can enable secure SSL connection. I also showed the example how you could do it using a database tool like PgAdmin, and I also showed you how you could do it using a terminal, for example. In this video, I will also show you how you could create a subnet. For example, your database is going to run in a particular subnet within a VPC, right? That's what I also show you. And I also show you how you could create a bucket in cloud storage so that you could take the backup of your database, right? I also show you how you could import and export databases, and watch this video carefully because I give you a lot of information about some practicalities. I also show you how you could connect to your database instance using PgAdmin, right? Also using a terminal. You're gonna see also automatic failover, how we could perform automatic failover, and a detailed overview of the database instance. So in today's agenda, what I have pointed out here in the hands-on session, you will see beyond that along with some troubleshooting. Probably I have missed out some of the bullet points here to include. So this doesn't definitely cover everything what I have in the video. So don't worry, I got you back because I have written the chapters in the video description, because this video is almost like 1 hour. So if you want to watch like 10 minutes a day, you could just go to the chapters, or whichever chapters are interesting to you, you could just click there and watch it. Thank you. Let's not wait anymore. First of all, I'm going to choose an existing project to create Postgres instance. From here, I'm gonna click on create instance because we want to provision a database instance for Postgres, right? We have got 3 database engines to choose from. Since this is about Postgres, we're gonna choose Postgres from there. In the instance info, I'm gonna call it demo PSQL YouTube. You could name it anything you want as long as you comply with the naming convention. We could also generate the password, right? So in this case, I'm going to put my own password. I'm not going to generate a password. Alright, and the version we're gonna choose 13. At the time of recording this video, 13 is the latest version. Alright, in the region, since I'm in North Europe, so I'm gonna choose my region from the drop down. You can choose according to your needs, and single zone is basically for the dev or testing environment, right? So in case of outage, there is no automatic failover. So this is not recommended for production, right? If you are working with any non-prod environment, then you could probably choose single zone, because that's how you could save some money, right? So in single zone, we will have always one single instance running. If the instance is for some reason down, it means that our database is down. For multiple zones, meaning that we're gonna have more than one instance running for our database, right? And this is HA, like highly available, and we're gonna have one in primary zone and one in secondary zone. So actually we will have two running instances, one in primary zone and one in secondary zone. But in this case, I let Google handle it for me. I don't want to choose any particular zone for this, since we have only three, so let Google choose the best option for me. This section is all about money, right? Because this is about database configuration, how powerful database instance you want to provision. So the majority of the cost actually comes from the database instance. So the more powerful instance you want, the more cost you're gonna incur, apart from the network bandwidth and other related cost, right? So we have multiple options here to choose from. We could go for custom. I have chosen from the drop down memory optimized database instances. You can choose a different one if you want to, but this is a demo, so I just choose randomly high memory option. So in the custom, we can get maximum 96 vCPU and 13 gigabyte of memory. That's the maximum that we can get from the custom option, right? You can adjust the instance type based on your need, but in this video, I'm gonna go for 2-core CPU and 8 gigabyte of memory. So in the storage, I'm gonna choose SSD because that's faster than HDD, right? And you can see when you switch disk type, then the disk throughput will also differ, right? It's because SSD is supposed to be better than HDD. So if you are doing some production stuff, you can always choose SSD. In the storage capacity, we can choose from 10 gigabyte to 64 terabyte. So that's a huge number, right? We need to be very careful here when we choose our storage capacity. Let's say I'm gonna choose 10 gigabyte, right? But if I start with 20, after I provision the database, I cannot go back to 10 gigabyte. It's because you cannot shrink the database disk space size, but you can always go higher, but you cannot go lower. This is very important to remember. And you need to also check mark enable automatic storage increases, is because over the time when you get more data into your database, then you want to automatically grow the disk space size. To encrypt our data, we're gonna use Google managed encryption key. If we choose custom managed encryption keys, we need to make sure we have timely rotated our keys before it gets expired. So it means that we need to do more ops work. I'm gonna check private IP, and in the network section I can see default, is because that's the default virtual private network, right? The VPC here, virtual private connection. So I'm gonna choose my default VPC. By default is gonna be public IP. This is not a good idea because you do not want to expose your backend database to outside world, right? So of course, if you choose to have public IP, you can also filter IP addresses, but we're gonna see it after some time, no worries. Let's get back to the backup sections. Now let us jump into backup sections. After some time, we'll come back to the connection section. So in the backup section is about automated backups and point-in-time recovery configuration. So in the first option, automated backup, we can choose the backup time window, right? So we can change this time according to our needs in the future, and also we can say whether we want to backup our data only in one single region or we want to backup our data more than in one region. So we can choose that options based on our need as well, right? And number of days for backup by default is 7. So which means that we can go back to at any given time of our data from the last 7 days, right? We could recover any data from the last 7 days at any given time. For production use cases, we would like to checkmark enable point in time recovery because this is crucial to be able to recover our data in case of outage or for disaster recovery. We need to enable point in time recovery. This is very important to checkmark, right? So maintenance typically only takes place once every few months, right? And requires our instance to be restarted while updates are made, which disrupts service briefly. So in this context, we are talking about weekly maintenance window. So we can choose our preferred window. So let's say Monday I choose at night time because we have less visitors on our web pages or our services. So we choose 4 to 5 a.m. Order of updates, I don't really care. So I choose any. So Flux will allow to customize granular aspects of our instance, which means that changing the flags or customizing the values can increase or decrease the performances, right? So if you need to tweak your parameters in your Postgres database instance, so this is the place where you will choose different options based on your need and you can tweak your performances of your database instance. Flags are literally the parameters. So in this case, if you change any of these parameters or the default values, it would require a restart. So before you change any parameters in the flags section, I would recommend you know what you're doing exactly. It can mess up your database performance, so be careful. Insights falls into monitoring section of your database performance issues. So Query Insights helps you detect and diagnose performance issues in our database instance by examining queries using both historical and near real-time data. So enable it to understand database load, identity, slow queries, and gain visibility into apps that connects to the instance, right? This is very useful. If you are working with production grade database instance, you must enable this. Or you might have some other monitoring systems where you visualize your slow running queries, right? So if that is the case, you don't need to. But if you want to have this monitoring enabled into your database dashboard, then I would highly recommend you checkmark enable query insights because this comes very handy to understand how your database is performing in terms of long running slow queries. We can also enable additional features. These are optional, right? So in the additional features, we can store client IP address, store application tags, and customize query lengths, right? So if this is required in your case, you could also check them. Labels are like tags if you compare to Azure or AWS or Alibaba Cloud, for example. I will highly recommend you to label your resources. So in my case, I'm gonna put env demo. Let me add one more. So the labels are like key values, right? They are key values pair. So in the key, I'm gonna call it department. Short is like depth for department, and value is going to be operations. So if you have like production or staging, you could name it accordingly. I think I'm gonna go with these two. You can add more if you want to. I wanted to show you. This is just for demo, so with two I'm pretty good. Now let's get back to the connection section. As we talked about before, private IP. So I'm gonna choose default, which is my default VPC. Now we need to click on setup connections. First of all, we need to enable the API. So once that is done, in the next step, we need to allocate an IP range for our subnet. So if you have created subnet for that particular VPC, in our case default, I have not created any, so you will see it in that list. If you have not created any, you could create here, like I call it DBIPNet, and then we need to put the private IP range. So we could go for 172.16 or 192.16.10.0.0./24 IP range, or we can also go for automatic, but since I wanted to show you how you could do it manually, so I choose the first option. But if you wanted to go with the automatic option, you could also go. Once that is done, we can actually create the connection, right? Here what we are doing, actually we are creating subnet, which is part of our VPC. So that's what is happening right here. So when we provision the database instance, our database instance should get one of the IP from the given range from our subnet, right? And our configuration is done, and in the summary summary section, you can find information that we have configured for our database instances, right? So you can see memory, storage, DB version, region, IOPS, disk throughput, backup availability, point in time recovery. So in short, this gives the whole picture of our database configuration. We are all set. Now it's time to create our database instance. So if I remember it correctly, it has actually taken around 10 minutes to provision the database instance. If we click on overview, this gives a lot of information about database instances, how to connect to the instance. On the right hand side, we have the configuration information. If you look at carefully, it also tells you how you can connect to a database instance using Cloud Shell. And here you can see the database connection name, and in the operation and logs, we can see operation related logs. For example, when it is started provisioning the database instance. So for example, creation time, it has the log of the database instance creation time. So once the database instance created, it will also log the time as well here. Another example could be when you restart a database instance, you can see when the restart started and when the database server went up, right? Up and running. So you can see that info here as well in the operations section. And the other example could be when you create read replica, that log would be also recorded in the operations sections. So I hope you get the idea already. If we click on backups, we can see backups related configuration, and we can edit them as well if we need to update the configuration. So here is the overview of our backup configurations. In the replica section, we can also see if we have any replicas created for our primary instances. So in the database section, we do not have any databases at this moment, is because our instance is still provisioning. By default, there should be some default databases created by the cloud providers, right? In the user section, we should see also list of users. For example, Postgres, GCP also creates some default users for doing some particular task. We cannot see it yet, is because our database instance is not fully provisioned, so we need to wait until it goes up and running, right? In the query insights, we can monitor our database instances. The query insights sections is about monitoring, so you can always look into this board to understand your database better, how your database is performing under load. In this section, you can get monitoring information about your infra. For example, how is the memory load, how is the CPU load, how about the connections at a given day, right? And in the top query sections, you can also monitor slow, long queries. For example, how much time a long query has taken to execute, right? So this is very important, and you can go to certain hour or day or a certain day at a given time, right? So this is very important. If you have some other database monitoring tools, let's say Grafana, Munin or similar, so you can check the board in there, and you can also see the load like CPU, memory, IO connections, how much storage has been used, stuff like so. I'm going to pause the video and we'll come back once the instance is up and running. Alright, I'm back. Finally, our database instance got provisioned. Excellent. Wow, it has taken roughly like 10 minutes. So let us try to edit the configuration, and I will walk you through some of the important features here. So the main idea to show you what we could change and what we could not change after we have provisioned the database instance. First of all, you cannot change the region anymore. Secondly, we cannot change the database version anymore, right? We had version 13 and we cannot switch to version 12, 10 or 9. So that's not possible, and you cannot change the instance name as well. But we can change from multiple zone to single zone. That's absolutely fine, as you have seen. And we can also change the machine types. Let's assume a scenario that you have really heavy load on your database instance and your database actually cannot handle that, right? You have read replica, but probably you have a lot of write operations. So you want to change to a powerful DB instance. So later on, actually, you have that option, and this is really good. If you forgot to subscribe, please subscribe to the channel so that you get more content. Thank you. So now we have chosen a new machine type with 2-core CPU and 7.5 GB of memory. We will not change anything else. Let's go ahead and click the save button, and well, now we get this pop-up. Changes require restart. One or more changes we have selected will require our instance to restart. Restarting will shut down the instance along with all connections, open files, running operations. Furthermore, it says that the instance will be automatically restarted according to our activation policy. Now let me tell you the most important piece of information. Once you provision the database instance and you go to edit the configuration, let's say you want to even edit the label, it would require a restart. If you want to edit any of the values that you have configured there, database has to be restarted to take into effect the new changes. So editing the configuration do not change the database IP addresses, database connection name, for example. So it just updates the configuration. It doesn't change the IP address, neither the connection name, right? The restarting process takes a little bit of time. So therefore, I'm going to pause the video again and come back once the instance is fully up and running. If you are new to the channel, when I upload new videos to my channel each week, probably you could subscribe so that you get notified before everyone else. Let's create a database. Click on databases, and from here we should be able to create a database. Note that we cannot until our instance update is completed. So let's click on overview and we can get the updated information of our database instances. In the configuration section, you can see we have 2-core CPU with 7.5 gigs of memory. If you click on edit, and if you expand it, you can see we have the right configuration after the changes, right? So everything looks good. Our changes have been successfully updated. So let's click on user and we are going to create a test user. So I'm gonna call it admin and give it a password. I was thinking to show you also Cloud IAM option as well, but while recording this video I have completely forgotten to show it to you. So that way it works. In Cloud IAM you have user, you can bind that user to this particular database instance, and it's pretty straightforward, and that particular user can have access to the database instance. So now if you click on ellipsis, then you can see change password and remove. So we could change a user password or we could remove a user as well. So we have created a user. Now we want to create a database. So if you click on databases, and in here we are going to click on create database to create a database, right? And I'm going to call my database test DB. If we want to delete a database, just need to click on ellipsis and click on delete. That's it. That would delete the database. So far we have created a database and a user as well. So I think we could test our database. So we will try to open up a database connection using Cloud Shell. So for that we need to click open Cloud Shell. So Cloud Shell is provisioning the shell machine for us. The Cloud Shell actually comes with pre-built tools, right, with auto completion as well. So as you can see, it actually runs Cloud SQL Connect PSQL YouTube, which is our project name, and then the user, it didn't pass any database name like -- database because by default is going to connect it to Postgres database. So in the pop-up window, we can see Cloud is requesting our credential to make a GCP API call, right? So we need to authorize this. So once we authorize, we still get the error. If we read the permission denied error message on the console, that Cloud SQL Admin API has not been used in our project before and it is disabled, is because I have never enabled it. To fix this, we need to open a new tab, copy the URL, paste it, and enable Cloud SQL Admin API. Once we enable this, we are ready to go. We should be able to make connection. Click on enable button and that would enable the Cloud SQL Admin API. Everything looks good. Now we need to go back to Cloud Shell. So we're gonna run the command again, and this time as it looks it's going to work, right? So it's taking a little bit time for me. It has taken more than 2 minutes, I guess, if I remember it correctly. Now we have got password prompted. So in here the password we need to pass in is basically when we created the instance, we talked about generate password, right? So that's the instance password that we need to pass in for Postgres database. So once we pass in and you enter, we are successfully in. Wow. So if you look at list of databases, so we run \l command that will list the databases. So here we can see testdb, that is what we created, and rest of them are created by default. So Postgres by default, Cloud SQL admin is created by GCP. So if you run \du, it means that give me list of users. So we can get our admin user, which is part of Cloud SQL super user, and rest of the users are created by GCP. So if we read the user names, they are actually self-explanatory. It's because you can see Cloud SQL admin, Cloud SQL agent, Cloud SQL service account, IAM user, import export user, replica, and super user. So just by reading the name, we can already understand what they are created for. I will create a table, just a dummy table, and we are not gonna insert any data into it. So create table company, it has couple of fields like ID, name, age, address, and salary. So our table is created, and if you run dt, it will describe the table, and we can see Postgres is the owner, type is a table, and the name is company, right? And table is part of public schema. So that's the default schema for Postgres database. Excellent. So now let us connect to our testdb database. Before we were connected to Postgres database. Now this time we have to pass in the -- database flag here, and we had a different user, right? So we created admin user. So we would like to use admin user this time to connect to our testdb database. So we pass in the database user password here that we have created before. All right, let me type in the password, and we got connected to testdb database successfully. So I'm going to create another table called department. This has no data in it, just the structure of the table, and this is part of public schema as well, and this time owner is admin, right? And the name of the table is department. Excellent. If we run d, and which means describe department, so you can get some information about that particular table. So you can see we had integer, id as an integer, department as character, and employee id as well. So you get information about the column and about the table as well, right? Excellent. Oh, I was typing it wrong as it looks. Actually, it would be \department, which means that describe the department table. So in our case, the table name is department, right? So it's going to describe the table, and when we describe the table, we can get the information about the column, type, collection, and other information. So now let us export a database. So we can have two file format. One is SQL, another one is CSV. So I'm going to go with SQL format, and the table we want to export, that is called testdb. Destination is going to be cloud storage. So we are going to create a bucket, and this bucket name has to be unique, right? So you do not put your username, neither the region name. You name it as you like, and location type is going to be a single region. I'm okay. If you want to go multi-region, that is what you could do as well. And I'm gonna go with one single region, and I choose my location, so Finland. All right, the region is going to be Finland, and you could choose also something else if you want to go for. Okay, I changed my mind, so I'm gonna choose Poland instead of Finland. So there is one region also in Warsaw, so I'm gonna choose Poland. So I'm gonna go with Poland, and type is going to be standard, right? We are okay. You can also call the line if you want to. So there will be separate tutorial about cloud storage, bucket, and all those types of stuff. So in this video, I'm not gonna talk about it. So I'm gonna go with the standard one, right? And for the public access, I'm gonna put the enforce public access prevention on this bucket, because I do not want to make it public, right? I want to make it private. And for the encryption key, I go with always Google managed encryption key, so that I do not have to rotate my keys. Retention policy, I think 1 day is okay, since this is demo. So by setting retention policy 1 day, we are telling cloud storage, hey, these bucket objects must be protected from deletion, right? Or modification after they're uploaded. So after 1 day, going to be deleted from the bucket. And we also want to add labels. Labels are really good and important. You should do that when you do the automation. It's really important to have a label. So the name is going to be DB backup bucket. Let's add one more. We call it env demo. Let's create this. Once bucket is created, we will be able to export the database dump data file to the cloud storage. So at this moment, it is exporting the database dump to cloud storage, as you can see, right? Our database is too small. It has only one table. Table doesn't have any data in it, so it should be fairly quick, right? As you can see now, our database exported to cloud storage, and this is not set to public and Google managed encryption keys we are using. If you click on that ellipsis, then you can have download, copy, move, some shortcut options there, right? And now we could import it. So to import is very simple. So we need to browse. So this is gonna take to our cloud storage bucket, right? And this is where we have the exported file. So we export the file and format is SQL, and the database right now, the destination database is going to be Postgres, because we are not putting testdb at this moment because our dump was taken from testdb. The owner is going to be admin. If we do not choose, it's going to be Postgres, right? Because Postgres is the owner of Postgres database. So this is going to be like less than a minute or so. So once this is done successfully, we should be able to see a table within Postgres database. So to see that, we need to connect to our Postgres database, right? Because that's where we have restored the testdb database, right? Let me go back to Cloud Shell and \q to exit the terminal. Now we would like to connect to Postgres database. So for that, we will change the user to Postgres. We do not have to pass in the database name here because by default it is going to be Postgres. Waiting for the password. Let me type in my password. Boom, we are in. So if I run \dt, it is gonna list me the tables, right? So we have got two tables. One came from the database restore, which is department. If you have noticed, using export, we cannot export a particular table. We can only export a database. So if you need to export a particular table, probably you want to use some other tools to do that. If you are interested, you can just write some PSQL commands here and play around with the database, right? Database tables, schemas, and all those cool stuff. So you can run gcloud, or you could just use PSQL command, or you could use some of the tools to access the database, right? Remotely. So there are a couple of options, but now let's look into clone option. Clone is a separate independent copy of your primary instance. So you can basically create a copy of your database instance for a particular time period. For example, let's say you wanted to create the exact copy from yesterday 3 o'clock. From an earlier point in time, you could do that. As you can see, you could choose your day, you can choose your time. But let's say if you have the production grade database where you need to recover your data from milliseconds, right, of transaction, let's say from 12, 28, 54 seconds we're talking about, but you want it to go to milliseconds, you cannot do it from the UI. To do that, you need to use actually the CLI. So remember that. So when you do this, it will create the exact copy of your database instance. So let's say the size of your database instance, let's say if it is 2 CPU core with 4 gigs of memory, so it's gonna be the exact copy of that. So when should you be using cloning? So we use clone for data recovery for certain day, or if you needed to debug some database related or application related issues. I'm not going to create it because it's gonna take time. Now we are going to play with failover. We're gonna trigger a manual failover. We're gonna test it how this works, right? So I'm gonna name it demo PSQL YouTube, right? So the instance will not be available for several minutes while the failover is taking place. I just wanted to remind you that we had a multi-zone instance, right, within North Europe. So our instance is not running in one zone because we have selected multi-zone database instance, right? So now we will actually trigger the automatic failover. This is a manual failover trigger, remember that, and this is gonna take some time to do the automatic failover. Your database is going to be unavailable. You cannot access your database anymore during this process. So let's say I get out of this terminal and I try to connect using Cloud SQL connect command. As you can see, using Cloud Shell, we are not able to connect to the database instance. It's because the status code, you can see 409, the instance's operation is not in appropriate state to handle the request because it cannot take any, is actually going through the automatic failover. So during this process, we cannot do any operations, right? So we tried multiple times, as you can see as a proof, and we have got, as you can see in the Cloud Shell terminal, we have got the error message. Let's recap. So what are we doing now? We are doing a zonal failover. Since we do not have a database instance running in another region, right? So we could have a read replica running in another region. So if we had a read replica running in another region, then the moment primary instance become unavailable, read replica should be promoted to be the primary instance. So automatic failover has successfully executed, right? So now if we are running the same command again, it seems like something is popping up. So it's waiting for the password. So we need to pass in the database instance password and we are able to connect to our database testDB, right? All right, so just to remember, just to let you know, when you do a manual trigger, your database instance is going to be down for certain amounts of minutes, a certain period of time, and you are not going to be able to connect to the database. Just to summarize, basically what we did a zonal failover, right? So let us create a read replica. So we are going to go for single zone and is going to be within the same region, North Europe 1, Finland. What is a read replica? A read replica is a copy of the primary instance that reflects changes to the primary in almost real time in normal circumstances. So you can use a read replica to offload read request or analytics traffic from the primary instance. Additionally, just a while ago we talked about disaster recovery, so you can perform a regional migration. So if a replica is a cross-region replica, you can perform an automatic failover to another region. Specifically, you can promote a replica to a standalone instance. During this process, we cannot connect to our primary database instance, as you can see in the Cloud Shell, right? We are trying to connect to our database instance, but we are not able. We can actually see the information about our database instance, but Google Cloud will not let you connect during this process. So whenever you create a read replica, remember that you cannot connect to the database instance. So if you go to the operations, you will see the logs. So right here you can see operation in pending, and the operation is about creating replica. It will have the starting time, it will log the starting time and the job completion time. So when read replica is created, you would come back to operations and you can see the log here that the read replica is created successfully. So I think it has taken roughly like 6-7 minutes. I can't recall it, but if your database instance size is a little bigger, then this might take a little bit more time. So when you create the read replica, I forgot to mention, this is also going to be the exact copy of your database instance. So during this process, when we try to connect to the database instance, we get the error Cloud SQL connect error, so HTTP error 409, which means operation failed because another operation was already in progress. While this operation is going on, let me change the theme of my Cloud Shell. So I'm using dark, probably light would be better for the viewer. I think this looks a bit better. I could change the font size as well, or or maybe I would stick to the font size I have currently and then change back to dark. So which one is good for you guys? I believe the light one is good, but for me, when I work on my computer, I prefer the dark one. It's good for eyes and also saves your computer battery as well, right? When you were working quite many hours in front of your computer, I prefer to use the dark theme instead of a light one. But it seems like for the video, light theme would be a good choice. So maybe next time I will keep that in mind to use light theme instead of using dark theme. Let us get back to Cloud Shell terminal, and now we could actually run the command. It seems like from the operations log, as you can see, instance is being updated, meaning that the job is completed successfully. So if we try to connect to our database instance, we get prompted for the password, right? So we can connect to our database testDB successfully. Excellent. So as you can see, we can see the table department that we had before. So in the read replica, right, we should have the exact copy of our testDB database as well. So if we try to connect to the read replica database instance, we should be able to see the exact data like we have in our master, right? There could be a little bit lag when you have the read replica in a different region, maybe milliseconds or seconds max. But if you are in the same region, you should be able to see almost real time. So if you click on Query Insights, you can see you could get 7 days data without paying a single penny, right? So it's completely free until 7 days. So if you need to monitor your performance issues of your database, you could enable Query Insights. This is really handy, and in production databases, it's gonna save a lot of time when you want to see which queries are actually taking a lot of time or how much time is taking. If we click on backups, we can see when backups are created, and the associated logs are also there. So you could delete or you could restore, as you can see on the right hand side. So if you want to restore, you could restore for a particular day. Let's say I want to restore yesterday 12 o'clock 10 minutes, for example. That is also possible. But if you have mission critical database systems where milliseconds, let's say your transaction data of milliseconds is also required to recover, then you need to use the CLI command, because in the UI you cannot do that. So when we created the read replica, it will have exact same configuration in terms of memory, disk and CPU. But after the read replica is created, we could go to the edit option, and right there we could change our configuration as well. For example, we could increase the memory or we could add a new label. So we click on replicas, and from there we can find the replica instance name, right? So we click in there, and on the top you can see a couple of options. So one of them is promote replica to primary, which means that promoting a read replica stops replication and converts the instance to a standalone primary instance with read and write capabilities. Note that read replica can only read. So once a read replica is promoted to be the primary instance, that immediately it would have the capability of read and write. Before it used to be read, but now after promoting it should have read and write capability. Click on disable read replica. So it's basically disable replication. So if we disable the replication, it doesn't mean that the standby database instance will stop. So it's gonna still run, and we're gonna incur charges for it. We will be still able to access to the database instance. So in this case, the secondary database instance, which is the read replica one, right? But it's not gonna replicate any data from primary instance to the replicated instance, right? Once the changes are applied, it will stop immediately replicating data from primary instance. It takes a little bit time. I don't remember, probably a couple of seconds or less than a minute, let's say. So anyway, we can go to operations and we can see the logs there. As we are now in replica instance, if you see on the left hand side, so you can see we are in the replica instance, so the operation should be shown associated with replica, right? So you would not be seeing the operations that was performed in the primary instance. So primary instance and read replica operations logs are completely isolated. Just keep that in mind. If we click on the ellipsis, then we can see a couple of shortcut options. We can edit, we can create more read replicas if needed, we can connect to a particular VM virtual machine, or we can also clone it. So this is kind of like shortcut. So if you needed to do something quickly, you can just come over here. So in this dashboard, if you look at carefully, the demo PSQL YouTube is the primary instance, and you can see all the available read replica under it. However, in case of read replica, if you go to users, databases, you could see still the same number of users that we have for primary instance with the same privileges, and for the databases, they should be the exact number. So we had Postgres and we had TestDB, right? So in the users and databases, there should not be any changes. They should be exactly as it was in the master database, so which is like primary instance. So now we are going to look into the connections part. Before, we have connected to our database instances using zCloud shell, right? But now we want to connect from our local computer. So to do that, I need to know my IP address, and if I know my IP address, then I could whitelist my IP address, right? So that I could get connected from outside of this network. So I'm gonna connect from my computer. This is why I will add my IP address right there. So I'm gonna save it. Once my IP address is saved, I could connect using PgAdmin, or I could connect using any other tool like DB Weaver, or just simply the terminal, right? So I'm gonna do it both ways, but in this case, first of all, let's go with PgAdmin. And if you have not installed PgAdmin, you could just download it from the internet and just install it. It's very simple. So first of all, we need to set up the connections, right? So click on servers, and then we need to set up the connection configurations. So in server, we need to click on connection, and in the host address, the connection name would not work. Instead, we need to put the public IP address and username database instance. So you need to put the particular username along with the password for it, right? And then the default port number is 5432. So and then the default database also Postgres. So we do not have to change anything unless we want to. So if you try to connect using connection name, we are not able to connect. You would be able to connect using Cloud SQL proxy. So if you download the binaries and then give the execution permission, then you should be able to do that. While I recorded this video, I completely forgot to show you how you could connect to the database instance using Cloud SQL proxy. Maybe in MySQL, probably I will try to add that in the hands-on session. But in this video, we're gonna show you how you could connect to your database instance using PgAdmin 4, right? So the setup is very simple. You just put your username, password, and the database name, right? And the endpoint. So in this case, we do not have a DNS name, so we pass the public IP address. Public IP address, as you have seen, we have whitelisted our IP address to do that. We could connect using the IP address, so I'm using the IP address right there. So once it connected using the IP address, we have got connected to our database instance, right? If you can see on the left hand side, we can see TestDB, and right there we can see our tables. So if you click on tables on the left hand side, so that would show you the tables, list of tables that we have, or any constraints, columns, and relays to the tables. All right, excellent. So we got connected to our database instance, and now you could do create, delete, update, whatever you would want to do, you could. So if you just right? We will create a dummy table, so we call it test table, and it's going to be under schema public, and the owner is going to be, as you can see, and we are not gonna pass in anything. This is just a dummy. I just wanted to show you that we could interact with our database instance right from our local computer. Excellent. So using this tool, you could write queries, you could create tables, select data from the tables, right? You could create indexes, drop indexes. So you get the idea, right? So you could use this tool if you don't like CLI. So there are other options. So as you can see, allow only SSL connection. We did not do that because if you have seen the warning, it was talking about that, but we simply ignored it because I did not want to enable the SSL part still. Allow only SSL connections. We did not enable it. As you can see, this is recommended when you connect using public network, right? We could still connect to our database instance from a client machine, right? Just whitelisting the IP address, but we wanted to have a secure connection instead, which is really good to have. So whenever you connect to your database instance, of course, you whitelist your IP address. It is also good to secure the connection, right? So therefore, we could enable the SSL connection. So we need to just check mark that part. You do not need to use SSL connection. For example, if you're connecting from the same VPC, right? So if you want to connect to your database instance internally, so you don't have to. So click on allow SSL certificate. Remember that when we create the Postgres database instance, the SSL certificates are also created automatically for us, and they get expired after 10 years. So you do not have to manage them, right? And you can see the expiry date right there, 2031, right? So after 10 years. And what you need as a client to get securely connected to your database instance is to download these certificates, right? So we have got a couple of them. So we can create, as you can see, 10 SSL client certificate for each database instance, right? So I'm gonna give it a name, GCP SQL cert or whatever client cert basically. So you're gonna create it, right? And it's gonna give a couple of links for us. So download client key.pam, download client cert.pam, download server ca.pam. So we need to download these certificates to our local computer, and the last command psql ssl mode equal verify, it exactly tells you what you have to feed in, what you have to pass in when you try to connect using psql command, right? So we got downloaded all 3 of them on my local computer, right? So I could use actually PgAdmin here. So what I have to do, I just need to go to the path where the certificates are downloaded, put the path here. So it seems like when I tried to do that, there was some issue with PgAdmin and I was not able. So when I tried to click on those 3 dots so that it will browse me to my computer file systems, right? It did not do that for some reason. So what I did to get over this, I needed to restart PgAdmin, and then I was able to do it. So I was like kind of like, what is going on? So don't get confused. What you do in this scenario, just kill the PgAdmin, and or you can just restart it, right? So this is the folder where I downloaded my files, right? So the cert files are downloaded in my local computer's download folders. So this is the command I just copied from there. So you could paste it, but this command would only work if the path is correct. In my case, this is not going to work. As you can see, the first warning is about the file permission. So what it wants us to do is to change the file permission. So 6 0, right? So it means that only user can read and write group, and then the other cannot do nothing with this file, right? So since these files should be secret, right? So only owners should be able to read and write them. So actually, technically, you should not have write permission. You should have only read permission. Instead of using 600, we should be using 400, so that only owner can read, because you do not want to manipulate the search, right? So this is the command. The reason it didn't work is because I have my old cert downloaded in this computer for other instances. So, and by default, the names are like the client cert.pam and so forth and so on. So this is why mine is failing. So to get it working, I need to rename my old certificates, and or I could rename the newly downloaded certificate's name as well. Either way is fine, as long as the path is correct to the file, right, to the certs. So this is the reason it's not working in my case. So if I run ls-lrt or ls-la, and as you can see, when I run this command, it actually shows me I have got more than one cert there. And so what I could do, I could rename it. So I just renamed it to pam.old, my old certificates, and the new certificate is called, this is the certificate we just downloaded for Postgres, right? So we could call it to client key.pam. So if the old certificates are not important to you, you could just completely remove them and get rid of all the problems that it brings, right? So now we rename the certificate because we actually gave the file permission to the old certs, not the new one. So as you can see, we have done a little bit of, we got tricked because I had got old certificates. So now what I want to do, I want to give the permission for the new certs, right? File permission. So instead of 600, use 400. This would still work for you. But as they recommend to use 600, so I'm just gonna show you for this video 600. But personally, I would use 400 instead. So I'm gonna remove the certificates, the old one. I don't really need them because I could download them later on if I need them to connect. So this is just extra debugging session, which I thought could be useful if you encounter these kind of issues while you go to work on Postgres database instances, right? So sometimes things happen like that you forgot that you have some certificates in certain directory. They are pretty old and you don't remember, you just download new stuff, and then you try to figure out, oh, what is wrong, what is going on actually. So this is a good reminder for those people who has such scenarios. So in my case, I have this scenario, so I also wanted to show you. If you don't want to, you can just skip the video for this part. Since we have given the right permission to the certificates, if we tried the same command, it would have worked, right? So now we downloaded the new pair, downloaded the certs again. This is for the people who doesn't have the old certs in their computer. So we start from right there. So we need to give the permission as we have given before. So in this case, 600 to the cert files, right? So in this case, client key.pam, server ca.pam, right? This is, in this case, in our case, we need to do only client key.pam, right? And if we run the command, it works. So you can see we have used SSL mode equal verify -ca. So now we actually go through this secure connection when we connect to our database instance outside of Google Cloud Network, right? So this is the way you could use you could use certs to get connected securely to your remote database instance. So I hope you get the idea. It's pretty simple. Just download the file, give the right permission, and put them in the command line or PgAdmin. We were talking about PgAdmin some time ago, right? And we were not able to connect. So because we had issues with the with the tool PgAdmin, because it just hung up or something. So it was just frozen. It didn't work. So now we're gonna do the same from PgAdmin. So this time we're gonna pass in the endpoint, the IP address, the port, the default database, Postgres, and username, and then the password. Now if I click right there, you can see it takes me all the way to my file system computer. Local computer file system. So in this case, I'm going to put the client certificate location, and then I got connected. Excellent. So as you can see, I got connected to the test DB, Postgres, all of the two of the databases we had. We can see them after we get connected. So now you can see the tables department and test table that we have created a while ago. They are all intact. So it seems like everything worked. In terms of secure connection, we used PSQL command using a terminal, and then we also using a tool, right? So both ways we were able to connect to our database instance, right? So that one I didn't show you using Cloud SQL proxy, which is basically binaries that you need to download and then give the execution permission and then run the Cloud SQL proxy command that will let you do it. So what happens if you want to connect to your replica instance? This is exactly the same procedure. So you need to just allow SSL on, and then you download the certs like we did for primary instance, and then you give the permission. So it's the same procedure. I'm not gonna repeat the same thing again. So I hope you get the idea, right? So in this case, right now I'm gonna delete the replica instance because I don't really need it, because this was just for this video purpose. So I'm gonna delete it. If you need it, you could also stop it, and later on you could start it as well. For example, the primary instance, you can, for now, I'm gonna stop it. Right now it's not going to stop because the replica instance actually right now in progress of deletion. So we cannot delete until this operation is going on. So once the replica is deleted, then I would be able to stop my primary database instance so that I do not incur bills for it, right? So once this is done, if you want to save some bucks, you can stop the database instance, and later on when you were working later on you could start it. So this is just a convenient way to save some money, right? So as you can see, the replica instance got deleted. So now I should be able to stop my database instance. Thanks for watching the video. If you like the video, do not forget to like, comment, and subscribe. And see you in the next one. Stay tuned and stay safe, people.